Welcome to Tungal Online Classes. Today we are going to discuss about the concept of the escape velocity. So already you know the definition of the escape velocity. What is the escape velocity means? The minimum velocity with which a body will be projected. The minimum velocity with which a body will be projected. As a result, the body will be escapes. The body will be escapes from the gravitational influence of the given planet. From the gravitational influence of the given planet, such a type of minimum velocity we are calling as a what? Escape velocity. Already you know the definition of the escape velocity also. So, the escape velocity will be represented by the symbol, the escape velocity will be represented by the symbol V suffix E, V suffix E. So, we have to discuss about the total energy of a given body. Whenever the total energy of a given body will be negative, whenever the total energy of a given body will be negative, the body will be compacts to the surface of the given planet, or the body will be bounded with the gravitational field of a given planet. So that whenever the total energy of a body will be negative, so what we have to understood that a body will be bounded to the given planet or a given massive object. If total energy will be is equal to 0, the total energy will be is equal to 0, then what happens means the body will be entered into the space, interstellar space with a zero velocity, This point is a very important. Whenever the total energy of the body will be is equal to 0, the body will be escaping from the gravitational influence of the given planet and it will be entered into the interstellar space. It will be entered into the interstellar space with a zero velocity, If the total energy of the given object will be positive, it will be escapes from the gravitational influence of the given planet, as well as it is also having some definite velocity, in the interstellar space. These 3 points we have to remember. If a total energy will be negative, what happens? The body will be bounded to the given planet. If a total energy will be is equal to 0, the body will be entered into the interstellar space with a zero velocity. If the total energy will be positive, the body will be leaving the gravitational field of a given planet and it was entered into the interstellar space with a certain velocity, Now, we are assuming that a body will be projected with a minimum speed, That minimum speed only we are calling as a what? Escape velocity. Whenever the body will be projected with the minimum speed, it will be escapes from the gravitational influence. At that instant, the total energy of the given object is equal to 0. This point we have to remember. Whenever any one of the body will be just projected with the escape velocity, its total energy value is equal to 0. So here two different cases are there. In case 1, we are projecting the body from the surface of the earth. We are projecting the body with a minimum velocity, that is nothing but escape velocity from the surface of the earth, Whenever we are projecting the body from the surface of the earth, now we are going to derive the formula for the escape velocity. So, whenever the body will be projected from the surface of the earth, initially the body will be present on the surface of the earth, so that it is having some definite potential energy. So, what is the potential energy general formula? Potential energy is equal to minus gmm by r. So, whenever the body will be placed on the surface of the earth, its potential energy formula is equal to what? Minus gmm by r. Now, here the body will be projected with a certain minimum velocity, so that this object is also having simultaneously kinetic energy also. The kinetic energy of the projected body is equal to what? Half mv square. Already we told, whenever the body will be projected with the minimum speed or escape velocity, its total energy value is equal to what? 0. Therefore, total energy should be equal to what? 0. Total energy means what? Potential energy plus the kinetic energy value is equal to 0. So, what is the potential energy value? Minus gmm by r plus half into m VE square. What is the VE means? Minimum speed. That is nothing but escape velocity. Minus gmm by r plus half into m into VE square is equal to what? 0. If you simplify, you will get VE is equal to VE square is equal to 2 gm by r. VE square is equal to what? 2 gm by r. Therefore, VE is equal to under root of 2 gm by r. V is equal to what? Under root of 2 gm by r. So this is a general formula for the escape velocity whenever the body will be projected from the surface of a given planet which is having a mass of capital M and radius is equal to what? Capital R. So here VE is equal to under root of 2 gm by r will be representing the expression for the escape velocity of a given planet. Escape velocity of a given planet. Next, already we know that small g is equal to gm by r square. Small g is equal to what? Gm by r square. So that is the relation between the small g as well as capital G. So in the place of gm, I will write g into r square. Therefore, the escape velocity, another formula will be given by 2 into gr square by r will be getting cancelled. Therefore, another formula for the escape velocity is equal to what? Under root of 2gr. Under root of 2gr. These are the two important equations for the escape velocity whenever the object will be projected from the surface of the earth. Projected from the surface of the earth. So this is about the first case whenever the body will be projected from the surface of the earth. Now we are going to discuss about the escape velocity when the object will be projected from certain height from the earth surface. Certain height from the earth surface. See the case 2. In the case 2, what we are saying that the same body will be projected at a height of small h above the earth surface. Here also we are assuming that whenever the body will be projected with a certain minimum velocity, here also the same body will be escapes from the earth gravitational influence. So here also first we will write the general formula for the potential energy. What is the general formula for the potential energy? Whenever the body will be placed at a height of small h above the earth surface means potential energy is equal to minus gmm by r plus h. Minus gmm by r plus h. So whenever the object will be placed at a height of small h above the earth surface, the potential energy formula is equal to what? Minus gmm by r plus h. Next, from this position, the body will be projected vertically upwards with a certain minimum velocity, so that the kinetic energy formula will be given by half m VE square. Half m VE square. So here also what we are saying that whenever the body will be projected with a certain minimum velocity, the body will be escapes. The body will be escaped. Whenever the body will be escaped. So whenever the body will be escapes. So what is the condition here? Total energy is equal to, total energy of the body will be is equal to what? 0. Whenever any one of the body will be leaving the gravitational influence of the given planet, the total energy value is equal to what? 0. So here also we are going to equate the total energy equal to what? 0. Minus gmm by r plus h plus half m VE square is equal to 0. VE square is equal to what? 0. If you simplify, you will get VE square is equal to 2 gm by r plus h. VE square is equal to what? 2 gm by r plus h. Therefore, escape velocity is equal to 2 gm by r plus h. So this is the formula for whenever the body will be projected at a height of small h above the earth surface, the formula for the escape velocity V is equal to under root of 2 gm by r plus h. So this is the concept of escape velocity. Now see, some different cases are given. Behavior of a body projected vertically up with different velocities from the surface of a planet. So that here they mentioned that a body will be projected vertically upwards from the surface of the earth with different velocities. Whenever they will be projected with different velocities, they discussed that what is the behavior of the body in each and every case. In the case 1, they are saying that if the velocity of projection will be less than escape velocity. In the case 1, what they are saying that the velocity of the projection value will be less than the escape velocity, then what is the state of the body they are asking. See, already we told, whenever any one of the body will be projected certain minimum velocity, then the body will be escapes from the given gravitational influence of the given planet. But in this case, the velocity of projection value will be less than that minimum velocity. So in this case, the body does not escapes from the gravitational influence of the given planet. Why? If any one of the body has to be escape from the gravitational field of any one of the planet, that minimum velocity value must be equal to the escape velocity. That minimum velocity value must be equal to the escape velocity. If the velocity of projection will be less than that minimum velocity, that is calling as escape velocity, then the body does not be escapes. Then what happens? So whenever the velocity of projection will be less than escape velocity, the total energy of projected body will be negative. The total energy of the projected body will be negative. Already I told in the starting of this lecture, whenever the total energy of a given body or a given electron will be negative, that a body will be bounded to that system. So here, whenever the velocity will be less than VE, what we are saying that the total energy of the projected body will be negative. Whenever the total energy of the projected body will be negative, means that the body will be travels to certain maximum height, and again it is falling backwards onto the surface of the earth. So that whenever V is less than VE, what we will observe that the body will be reaches the certain maximum height and falls back. Whenever the velocity V will be less than VE, it reaches certain maximum height, again it is falling backwards like a vertically projected body. Now, if it is reaches some maximum height, I want to calculate what is the maximum height reached by that body whenever V will be less than VE. So, according to the law of conservation of energy, total initial energy is equal to total final energy. Total initial energy is equal to what? Total final energy. So here the body will be projected from where? The body will be projected from the surface of the earth. So that whenever the body will be projected from the surface of the earth, it is having certain potential energy as well as kinetic energy. So I will write initial energies of the projected body. What is the initial energy? Initial potential energy is equal to minus gmm by r. Initial potential energy is equal to what? Minus gmm by r. Why? It is projected from the surface of the earth, so that if any one of the body will be placed on the surface of the earth, its potential energy will be given by minus gmm by r. Next, initial kinetic energy half mv square. Initial kinetic energy is equal to what? Half mv square. Why? The velocity of projection will be taken as a what? V, and its mass is equal to m. Next, whenever it is projected with a velocity v, what we are saying that it reaches some maximum height. Already we know the basics. If any one of the body will be reaching the maximum height, the final velocity of the object at the maximum height is equal to 0. The final velocity of the object at the maximum height is equal to what? 0. So that its kinetic energy value will be is equal to 0. Its kinetic energy value is equal to what? 0. Final kinetic energy value what? 0. Now, what is the final potential energy? Since the object will be at a height of small h above the earth surface, therefore its potential energy will be given by minus gmm by r plus h. Minus gmm by r plus h. This is the potential energy. Kinetic energy value is equal to 0. Now we will simplify. Half mv square. If this term will be bringing towards the right side, it becomes to what? Plus gmm will be the common. 1 by r minus 1 by r plus h. 1 by r minus 1 by r plus h. So m will be getting cancelled. So we need the h value. Half into v square g into capital M, r plus h minus r by r into r plus h. R will be getting cancelled. So that if you simplify that value, half v square is equal to gm into small h by r into r plus h. R into r plus h. So generally we know that small g, acceleration due to gravity, is equal to gm by r square. Acceleration due to gravity is equal to what? Gm by r square. But here I have only gm by r. For getting r square, I will took r will be as the common from r plus h. R plus h. So that half into v square gm by r square into 1 plus h by r into h. 1 plus h by r into what? H. So here in the place of gm by r square we will write small g. Therefore half into v square gh by 1 plus h by r. 1 plus h by r. So if you simplify this one, if you simplify that one, you will get h is equal to r by v square by v square minus 1. If you simplify, cross multiply, all these things will be done. So the final result what you are getting, maximum height reached by the body is equal to what? Small h is equal to r by v square by v square minus 1. Here what is the v here? V will be indicating the velocity of projection and v square will be indicating what? Escape velocity. So this is the case one, whenever the body will be projected with a velocity v which is a less than escape velocity, Now we will discuss about case 2. See the case 2. In the case 2 what we taken here, if the velocity of projection v is equal to escape velocity, already we discussed the definition of the escape velocity. Whenever the body will be projected with the escape velocity, the total energy of the body will be is equal to 0. So what is the first point we have to understood? If any one of the body will be projected with escape velocity, the total energy of the body should be is equal to 0. Total energy of the body will be is equal to what? 0. So whenever the body will be projected with the minimum velocity, it will be escapes from the gravitational influence of the given planet and it just entered into the interstellar space. That means in the interstellar space, the velocity of the object is equal to 0. So whenever the body will be projected with a certain minimum velocity, it is just entered into the interstellar space or infinite region. At that interstellar space, the velocity of the object is equal to what? 0. In the interstellar space, in this case too, the velocity of the given object is equal to what? 0. Whenever we are projected at the body with v is equal to what? Ve. Next, in case 3, if the body will be projected with a velocity, greater than the escape velocity, see here, in the first case, if v is less than ve, what you wrote? Total energy will be negative. Whenever the velocity of projection will be less than the escape velocity, total energy will be what? Negative. If v is equal to ve, you wrote total energy is equal to 0. If the velocity of projection v is equal to ve, total energy value is equal to what? 0. If v is greater than ve, total energy should be greater than 0. So that in case 3, if the body will be projected with a velocity which is greater than the escape velocity, then what happens means the total energy of the body will be positive. Total energy of the body will be positive means the body will be having some kinetic energy in the interstellar space. Coming to here, whenever the body will be having the total energy is equal to 0, whenever the body will be having the total energy is equal to 0, the velocity in the interstellar space is equal to what you wrote, v is equal to 0. But whenever the body will be projected with a velocity v is greater than ve, what you are saying that the total energy of the given object will be positive. So that whenever the body will be projected with this velocity, the kinetic energy value is not is equal to 0. The final kinetic energy value is not is equal to 0 in the interstellar space. In the interstellar space. Now we will derive the expression for the velocity of the object in the interstellar space. Again we will write the total energy. Total initial energy is equal to what? Total final energy. Law of conservation of energy will be takes place. Since the body will be projected from the surface of the earth, so that its potential energy value is equal to minus gmm by r, minus gmm by r, and it is projected with a certain minimum velocity, so that is a half mv square. So that this is the potential energy of the object, this is the initial kinetic energy of the object. This is giving the total initial energy of the object which is projected from the surface of the earth. Now, whenever the object will be entered into the interstellar space, its potential energy value will be is equal to 0. Potential energy of the object is equal to 0 at the infinite distance. At the infinite distance, it have only the kinetic energy. Therefore, half m v infinity square, where v infinity is indicating the velocity of the given object in the interstellar space. In the interstellar space. Now we will simplify this equation. See here, 2 will be taken as the LCM, minus 2 gmm by 2r minus gmm by 2r plus half mv square is equal to half m v infinity square. Will be getting cancelled. Will be getting cancelled. See here, this value is equal to, here 2 is also getting cancelled, minus 2 gmm by r plus v square is equal to v infinity square. V infinity square. What is the general formula for the escape velocity? Under root of 2 gm by r. General formula for the escape velocity is equal to what? Under root of 2 gm by r. Here minus 2 gmm by r will be there. Minus 2 gm by r will be there. So that I will write this equation as, first I will write this term, minus v square is equal to v infinity square. V square minus v escape velocity square is equal to what? V infinity square. Therefore, v infinity is equal to under root of v square minus v square. So this is the required expression for the velocity of the object in the interstellar space. Velocity of the given object in the interstellar space. So these are the different cases whenever the body will be projected with different velocities. One is v less than ve, second one is what? V is equal to ve, third one is equal to what? V greater than ve. So this is about the complete information about the escape velocity concept. They discussed some important features regarding the escape velocity. The escape velocity will be independent of the mass of the given object. So what is the first point we have to remember? Escape velocity will be independent of the mass of the given object. Mass of the given object. Next, the escape velocity is also independent of angle of projection. The escape velocity is also independent of what? Angle of projection. So the escape velocity is also independent of angle of projection. So these 2 points we have to remember regarding the escape velocity. What is the first point? So the escape velocity will be independent of the mass of the projected body, as well as it is also independent of the angle of projection. And for the earth, the escape velocity value is equal to 11.2 kilometer per second. The escape velocity value for the planet earth is equal to what? 11.2 kilometer per second. So these 3 points we have to remember regarding the escape velocity. See the next concept, orbital velocity. So what is the orbital velocity means? In generally, the satellites are revolving around the earth in the circular orbits. The satellites are revolving around the earth in which type of orbits? Circular orbits. If they will be revolving around the circular orbit, they will be having certain minimum velocity and they require some centripetal force. So that if any one of the satellite will be revolving around the planet Earth with a certain minimum velocity, such type of velocity we are calling as a what? Orbital velocity. So how can we define the orbital velocity? Means the velocity of the satellite, which is revolving around the Earth in a given circular orbit, such type of velocity we are calling as a what? Orbital velocity. So here we are assuming that a satellite which is having a mass of small m will be revolving around the Earth in a circular orbit with the radius of small r as shown in the figure. Already we know that if any one of the object will be revolving in the circular path, it requires some necessary centripetal force. That required centripetal force will be provided by the gravitational force of interaction between the planet Earth and the given satellite. So that the centripetal force formula will be given by centripetal force is equal to mv0 square by r. This much of centripetal force will be acting on the given satellite, where m is indicating the mass of the satellite, v0 will be indicating the orbital velocity of the satellite, and r will be indicating the radius of the circular path. And the required centripetal force will be provided by the gravitational force of attraction between the given satellite to the Earth. So that the gravitational force of attraction formula will be given by F is equal to gmm by r square. If you equating these two equations, we will get mv0 square by r is equal to gmm by r square. mm will be getting cancelled, rr will be getting cancelled. Therefore, v0 square is equal to gm by r. Therefore, v0 is equal to under root of gm by r. So, this is the general formula for the orbital velocity. What is the general formula for the orbital velocity? v0 is equal to under root of gm by r. See here, on what factors the orbital velocity will be depends. It is depends upon the mass of the given planet and radius of the circular orbit. Already we know that small g is equal to gm by r square. Small g is equal to what? Gm by r square. So that from that we will write, so gm is equal to gr square. Equation number 2. Now here from the figure, actually what we have to write, r is equal to, what is the r? Radius of the circular orbit. The radius of the circular orbit is equal to what? R plus h. Radius of the circular orbit is equal to what? R plus h. So from this we will write the general formula for the orbital velocity. v0 is equal to under root of gm by r plus h. So the general formula for the orbital velocity, which is revolving at a height of small h above the earth's surface, is given by v0 is equal to under root of gm by r plus h. But whenever the satellite will be revolving very closer to the earth, if the satellite will be revolving very closer to the earth, this r plus h value will be taken as, a what? Capital R. So when we will took this one, if h will be much lesser than capital R, if small h will be much lesser than capital R, this r plus h can be written as capital R. Therefore, the orbital velocity formula will be given by under root of gm by r. For which type of satellites? For the satellites which are nearer to the earth surface. For such type of satellites, we are writing the orbital velocity formula under root of gm by r. But gm is equal to, you know that, g into capital R square. So that if you substitute that value, gm is equal to gr square by r, r getting cancelled. Therefore, v0 is equal to under root of gr. v0 is equal to what? Under root of gr. Next one. See here, in the orbital speed, they given some formulas for the angular velocity as well as the time period values. See here, we are assuming that the satellite is revolving around the earth in the circular path, having a radius of small r. So in this case, that satellite will be acted by some centripetal force. That centripetal force will be provided by the gravitational force of attraction. So I write the formula centripetal force in the form of mr omega square. Why? I need the angular velocity value. So that centripetal force will be written in the form of mr omega square, which is equal to gmm by r square. Here m comma m will be getting cancelled. Omega square is equal to gm by r cube. But if we are assuming that if the satellite is revolving at a height of a small h above the surface of the earth, so that the radius of the circular orbit is equal to small r is equal to r plus h. Therefore, I will write omega square is equal to gm by r plus h whole cube. Therefore, angular velocity omega is equal to under root of gm by r plus h whole cube. So this is one of the required formula for the angular velocity. Again, they are also asking the formula for the time period. Already we know that time period of omega is equal to what? 2 pi by t. Omega is equal to what? 2 pi by t. What is the omega value? Omega value is equal to what? Under root of gm by r plus h whole cube. Therefore, 2 pi by t is equal to gm by r plus h whole cube. So therefore, we need the value of t. Therefore, t is equal to, making the cross multiplication, 2 pi into under root of r plus h whole cube by g capital M. So this is the time period of a satellite which is revolving around the earth. By using this formula, we have to calculate the time period of a given satellite which is revolving around the earth at a height of small h above the earth's surface. And we will took some assumptions that if that satellite will be revolving very closer to the earth's surface, that means the height value will be very much smaller than the radius of the earth. In that case, we will write the values of omega as well as the time period. What is the omega formula here? Omega is equal to under root of gm by r plus h whole cube whenever h will be very small with respect to the radius of the earth. So here the h term will be negligible. Therefore, omega value is equal to under root of gm by, in the place of r plus h whole cube, we will write r cube. So whenever the satellite will be revolving, very closer to the earth's surface, so h will be very much small, so that r plus h value will be taken as capital R. Therefore, omega value will be given by under root of gm by r cube. Similarly, the time period value will be given by t is equal to 2 pi into under root of, here you wrote r plus h whole cube, but whenever the satellite will be closer to the earth's surface, we taken that r plus h value is equal to what? Capital R. Therefore, r plus h whole cube becomes to what? R cube by gm. Again here, we will simplify this equation, 2 pi into under root of r cube by gm is equal to what? Gm is equal to, already you know that small g is equal to gm by r square. Therefore, gm is equal to g into r square. Therefore, in the place of gm, I will write g into r square. R square cube will be getting cancelled. Therefore, it is an important formula. So that is time period of the satellite, which is revolving very closer to the surface of the earth, that the formula will be given by t is equal to 2 pi into under root of r by g. What is the r value here? The radius of the earth is equal to 6,400 kilometers and the small g value is equal to what? 9.8 meter per second square. If you substitute their values, you will get 84.6 minutes. Very important bit. So this is about orbital velocity concept. If you look at the time period of revolution, one more formula they will be given. T is equal to under root of 3 pi by 0. T is equal to what? Under root of 3 pi by 0. How this formula will become means, already we derived T is equal to 2 pi into under root of R by G. So this is the important formula for the time period of revolution of a satellite which is revolving very closer to the earth surface. T is equal to what? 2 pi into under root of G by R. But on the surface of the earth, you have a formula for the small g, that is 4/3 pi G R rho. You have a formula for the small g on the surface of the earth which is given by G is equal to 4/3 pi G R rho. So this equation 1 will be converted as T is equal to, whenever the 2 pi will be coming inside the square root, so that becomes to what? 4 pi square R by, in the place of G I will substitute this value, that is 4/3 pi G R rho. 4 will be getting cancelled, R will be getting cancelled, 1 pi will be getting cancelled. So that in the numerator here pi will be there. If this 3 will be going to the numerator, it becomes to what? 3 pi. Here 1 G will be there, rho will be there. So this is the another formula for the time period of a revolution of a satellite in terms of universal gravitational constant as well as the density of the given planet, where capital G will be indicating what? Universal gravitational constant, and rho will be indicating what? Density of the given planet. And they are also given one formula for the frequency of revolution. So we know the general formula for the time period T is equal to 2 pi into under root of R by G. T is equal to 2 pi into under root of R by G. But we know that the frequency is the reciprocal of the time period. F is equal to 1 by T. Therefore, F is equal to 1 by 2 pi under root of G by R. So this is the formula for frequency of revolution of a given satellite which is revolving around the earth. So that is about time period as well as the frequency of a given satellite. Say the next concept, geostationary satellite. Geostationary satellite. If any one of the satellite will be said to be the geostationary satellite, so it will be obeying some of the conditions. In its name only will be there, geostationary. That means those satellites are appears to be stationary with respect to the earth. Such type of satellites we are calling as a what? Geostationary satellites. So they have to obeying some of the conditions, that in generally we know that the earth will be rotating from west to east. Earth will be rotating from where to where? West to east. So that if any one of the satellite will be said to be the geostationary satellite, it is also rotating from where to where? West to east. So that the first point which is required means, if any one of the satellite will be said to be geostationary satellite, it will rotates from west to east. Then we will say such type of satellites are what? Geostationary satellites. And the second point is, we know that the time period of revolution of the planet Earth is equal to 24 hours. If any another satellite will be said to be the geostationary satellite, the time period of revolution of the same satellite must be equal to 24 hours only. So that if any one of the satellite will be said to be the geostationary satellites, its time period value will be is equal to what? 24 hours. 24 hours. Next, already in its name only will be there, geostationary satellite. So that the relative velocity of the satellite with respect to the earth. Third point, the relative velocity of the satellite with respect to the earth must be equal to 0. Why? Both are rotating from west to east, and both are having the same time period. So that the relative velocity of the satellite with respect to the earth is equal to what? 0. The relative velocity of the satellite with respect to the earth is equal to what? 0. That is the third condition. Next, fourth condition is a what? They will be rotating at a height of 36,000 kilometers. They will be rotating at a height of 36,000. If you take any one of the geostationary satellite, those geostationary satellites will be rotated and they will be placed at a height of 36,000 kilometers from the Earth's surface. So that is the fourth required condition for the geostationary satellites. Next, fifth one is what? Parking orbits. Parking orbits. So what is the parking orbits? So we will send the satellites from the Earth's surface to certain orbits which are revolving in that orbits around the Earth's surface. The orbit in which a satellite will be placed, the orbit in which a satellite will be launched, such a type of orbits we are calling as what? Parking orbits. So these are about geostationary satellites. Geostationary satellites. Next concept, polar satellites. Polar satellites. So what are the polar satellites? Already we told, in the case of the geostationary satellites, these geostationary satellites are revolving around the Earth. In which direction? West to east, west to east. Like this, these geostationary satellites are revolving around the Earth. But in the case of the polar satellites, these polar satellites are revolving around the Earth. These polar satellites are revolving around the Earth from north to south directions. North to south directions in the vertical plane like this. In the vertical plane. Such type of satellites are calling as a what? Polar satellites. Polar satellites. These polar satellites are revolving around how? So they will be revolving around the Earth in north to south direction. Next. The geostationary satellites are placed at what height? 36,000 kilometers height. They will be launched at very high altitudes. But in the case of the polar satellites, they will be launched at a heights of 700 to 900 kilometers. That is within 1000 kilometers only, these polar satellites will be launched. So these polar satellites will be placed very closer to the Earth's surface. Next, the time period of revolution of the geostationary satellites is equal to what? 24 hours. But in the case of the polar satellites, the time period of revolution of the polar satellites will be is equal to how much? 100 minutes. That means they will be revolving around the Earth with very high speeds, That's why these polar satellites will be used for security purpose, So this is about the theory part of gravitation. Weightless state will be there. Already you know that whenever the object will be falling with acceleration due to gravity, apparent weight will be is equal to 0. Such a state we are calling as a what? Weightless state. So in the next class we are going to solve the numericals of the gravitation. Okay, thank you.